Victoria Parent, and this is my project, Correlation of Fingerprints Between Immediate Family. So the purpose of this project is to prove if fingerprints are a genetically inherited trait similar to hair and eye color, despite no two fingerprints being the same. So overall, it's to see if fingerprints are similar between immediate family members. I pretty much picked this project because out of all the fields of science, forensics is what interests me most. I just find it very interesting how you can use parts of DNA to identify someone. So the hypothesis for this project is that if two people are immediately related to one another, their fingerprints will have similar patterns and classifications since they share large amounts of DNA, and this is ultimately based on, again, how traits can be genetically passed down from a family member to another. So the procedure for this project starts when I set up in a clean space. So this setup includes an index card box where a fingerprint will be put after it's taken, a ink pad where a finger will be placed and get inked up before it is put on the card. That's where the fingerprints will be. And before and after a person gets their fingerprint done, they are offered a wipe to clean their finger. Other materials being used include an iPad, a pen or pencil, and human consent forms. I'll get to those in a second. So overall, after I set up, the next step in the procedure is to find people. This could be anywhere in like a city, again, as long as it's clean. If a person agrees to be a part of this experiment, they will be given a human consent form. This could be digital or paper, depending on the preference of a person. And once they agree, I guide their finger to the ink pad, get ink on their finger, and I then guide them to a card where their fingerprint will be pressed down. Again, they'll be offered a wipe, and their role in the experiment is over. So once that's done, I will take their fingerprint and classify it. I will give an ID number, and I will say, most importantly, if this person is related to another person participating. If they are, they'll be part of the experimental group, not the control group. And the experimental group is this group because it's the one that's being experimented on. We're trying to see if there's a correlation between fingerprints of relatives and these people are the relatives. Again, once that's done, it will be repeated with all 100 participants. Once they get their fingerprint, it will go into the box where it's safely stored, and then the fingerprints that I took, all their classifications will be added in a data sheet. So what were the results of this experiment? Here I have 3 forms of what the results were. First one shows a control group, which was 80 participants, and it shows certain statistics like how much of these people had ulnar loops specifically. This number was 54. 54 people had ulnar loops, which is the most. Radial loops had 3, so overall 57 loops, which shows out of the 80 just how many people had a loop, proving it was the most in the control group. The rest are statistics about whorls. It's key to note that there was no arches present in this experiment. And the second one shows the experimental group, which was divided into 10 pairs of relatives, and how many of these relatives had the same classification or like slightly different things. So in red here, it shows that 7 out of 10 groups had the same major classification and same subdivision classification. Blue shows that they had different for both, and the orange shows that they have the same major but not the same minor classification. This last one over here shows overall statistics for both groups combined. The entire sample size of 100. For example, 2/3 of the total group have loops, a third has whorls. Again, it is key to note that there were no arches present. So what does this all mean? So, for one, we have to determine whether or not it supports the hypothesis. Personally, and as it should to you, it should show that these back the hypothesis that if 2 people are related, their fingerprints will be similar. So probably the biggest statistic is that 7 out of 10 pairs in the experimental group had the same exact classification. And another big point is that some of these classifications weren't just ulnar loops. As the data showed, ulnar loops were the most abundant fingerprint, which makes sense considering loops are the most abundant fingerprint in actuality in society. But not all of the pairs were ulnar loops. 3 of them were plain whorls, which, according to the entire sample size, only 16 people out of 100 had. So it's a rare fingerprint. It could coincidentally be in this many people, but considering that they're related and that it is a rare fingerprint, it is logical that the plain whorl was genetically passed down by these people. And the entire validity of this project is backed by the fact that the entire group is reflective of society. Arches are the least common fingerprint. We had no arches. Loops are the most common. We have many loops. This reflects society, and it is logical based on the real world. So what are the limitations to this? For one, it only documents the right thumb. Different fingers have different chances of having fingerprint specific classifications. So these are all tailored mostly specifically for the right thumb, where other fingerprints, if I took a finger, say if I did this experiment with a pinky, it would be totally different results because pinky has different chances of having specific classifications. Another one is that not all the whorls could be distinguished. There are 3 whorls marked as unclear. This means that I cannot distinguish them as a plain or central pocket loop whorl. So, although this is true, it does not affect the overall results as a whole because these were only 3 fingerprints and they're still easily identified as whorls. So one might continue this research by trying out a different finger or all the fingers with the same project to see if there's a correlation, because as I said, different fingers have a different chance of having a certain classification. Another way you could do this is use more advanced systems. So organizations like the FBI have access to databases like APHIS and IAPHIS, which are highly sophisticated sources that can sort through fingerprints, correlate them with people. It's much more sophisticated than what I have here, and it would truly maybe not change the results, but it would definitely make the results more believable per se. You also might continue this research by figure out why there's no arches, because there's not a single fingerprint that was an arch, and arches are the least common, but one could do research as to how they didn't appear in this project. Just how rare are they? So this has real-world applications as well. Theoretically, this research can determine someone's paternity or maternity to a child, or it could determine a sibling relationship. If you have 2 people who are assumed or may not be immediately related, you can use their fingerprints to lend evidence as to the truth. Also, if you happen to have a suspect in custody and you have a relative of theirs, and you have a print, say if you needed to, you can see if that print found at the scene has any chance of belonging to that suspect if you have a family member. Just things like that. So thank you so much for listening to my project. It's been truly an educational experience, and I'm grateful to have the opportunity.